Hello! We're gonna do proof by induction questions, and more specifically, the type of divisible by questions. We're gonna start off easy, the more simple types, and then we're gonna move on to the more tricky types of divisible by. So if you want to skip ahead or you want to watch the full thing, up to you, and you can be doing these questions while I do them too. So I'm going to be really thorough with the steps for this first question so that you guys, it's a refresher for how you guys to do proof by induction questions. So we start off with the smallest value of the set allowed. So n belongs to the set of positive integers. The smallest number is 1 in that set. So we start with let n equals 1. Substitute 1 into here. And that is equal to 12, which is divisible by 3. And that's the symbol for divisible by. And so we state that it's true for n equals 1. We move on to assuming true for n equals k. And we state that k cubed plus 11k is divisible by 3. Then we move on to proving true for n equals k plus 1. So a really handy tip to how to do the proving part here is you want to represent this part inside here, because you know this is divisible by 3, and once you get that in there, you get to solve a little bit of that question. So I'm going to show you how this works. So we substitute k plus 1 into these spots where n was, and then we personally, I feel like it's really useful to really just expand everything. So we're going to expand the cube and expand that. And so because we want to represent this down here, I'm going to actually rearrange this so that we can have the part from assume true for n equals k. And plus 12, because 1 plus 11. Okay. So now we know that this is divisible by 3, because it was up here and we assume true that it is divisible by 3. So in actual fact, we don't need to prove that this part is divisible by 3 anymore. And so we can just move on to working on this part back here. And another cool thing is that we know that actually all of this is divisible by 3, because this is just 3 and then k squared plus k plus 4. And so we've just proven that this, that it is true, and we need to state this. Therefore, true for n equals k plus 1. So since we've proven that this equation is divisible by 3 for n equals 1, and for n equals k plus 1 when we assume true for n equals k, we can write the final statement. And I'm only going to write the statement for the first question just to show you what it's like. So we write since true for n equals 1 and true for n equals k plus 1 when true for n equals k, then by the process of mathematical induction, and then this part I have to write by hand, n cubed plus 11n, is that correct? N cubed plus 11n is divisible by 3 when n belongs to the set of positive integers. Alright? So that's how you do it. Let's move on to a harder question. And this is just that little bit harder. Okay. So we're gonna start. So n belongs to the positive set of integers again. So let n equals 1. 1 times 1 squared plus 5 equals to 6. And that is divisible by 6. Therefore, true for n equals 1. We assume true. And you can probably skip this part just because it's going to be the same for every question. Okay. All right. So let's write out everything. K plus 1 all times of k plus 1 squared plus 5. And I think it's best just to expand this. So again, k plus 1 and times this by k squared plus 2k. 2ab, yep, 2k plus 1. Okay, and we plus 5 to this. So that makes it k plus 1, k squared plus 2k plus 6. Okay, so again, we want to see this part represented down here. So where do we see that? How do we do that? I think we need to expand. Yeah, let's just expand this whole thing. Let's expand this whole thing. There's actually a little bit of algebraic magic you can do. But I think it's best if we just expand the whole thing. So we have k cubed plus 2k squared plus 6k. Then that all plus k squared plus 2k plus 6. And if you didn't know what I just did, I took k times every single term, and then I took 1 times every single term and then added them together. Okay, and now we want to arrange it so that we see this. We see k squared plus 5. K times k squared plus 5. Well, that actually expands into k cubed plus 5k. So we actually have k cubed plus 6k here, and we can just detach that into 5k plus 1k. So what we're going to have is k cubed, k cubed plus 5k, because we're moving it, apart. Then we're going to add another k just to compensate. And then okay, just checking if I did any errors here. So k cubed, split that into 5k and k, 2k squared, 2k plus 6. Okay. Then we can say this is k times k squared plus 5. And then we want to just simplify this. So plus 3k plus 6. There we go. And since this part is, we already assume that it's divisible by 6, we can simply say that this is divisible by 6. And we don't have to worry about that part anymore. We move on to this part. And actually, there's something else we can do. 6 is divisible by 6. So we can actually rule out 6 as well. And we're left with 3k squared plus 3k. And we can factorize this into 3k times k plus 1. Now, if you're going to remember, like, there's not much to remember except the formula to do everything, like the general structure on how to write it. But with proof by induction, and they like to use this a lot, k times k plus 1. Okay. You need just a general idea first. To divide by 6, a number has to be divisible by 3, and it has to be divisible by 2. That's the rule, okay? And when we have a term like this, in fact, it's this or this. if we put k as any positive integers, this will always turn out to be an even number. And all even numbers are divisible by 2. Why? I'm just going to explain it real quick. Let's say that k is odd. And we're only going to use the top scenario. K is odd. What's going to happen is we're going to have an odd number times by an even number. Because odd number add 1, it's even. And an odd times even makes even. 2 times 3 is 6. 3 times 4, 12. Notice how though even times even, odd times odd is odd. 3 times 3 is 9. That kind of stuff. So when an odd times even is even, and also an even times odd is also even. And that's why down here is as well. So basically, when we have the scenario of k times k plus 1, and k is any positive integer, this means that these will always be an even number. And these will always be divisible by 2. So make sure you remember these. Remember these two. They're always divisible by 2 because they always end up as an even number. So what we're going to end up with is divisible by 2 and divisible by 3. And so in total, divisible by 6. And we just proved that all components of this is divisible by 6. And so therefore, true for n equals k plus 1. There you go. And you can, what you're going to do is rewrite the thing I did at the start, but I'm not going to do to save us time. So anyways, make sure to remember these rules because they use this a lot in proof by induction. Okay, moving on to this. Now this is a really tricky question. And actually, me and my tutor, we spent quite a while doing this. So we're going to start off. N belongs to positive integers. And this is where the method changed. We're not doing the other method anymore. This is going to be a new, I would categorize it as a new method to do this. It's same structure, just different method. So n belongs to positive integers. And so we start with let n equals 1. Then we substitute 1 into, and that is equal to, that looks like a 4. There we go. That's 25 minus 24, that's 1 minus 1, that's 0. And 0 is divisible by all numbers. So, therefore, true for n equals 1. Then we assume true, and again, if you want to skip this, it's okay. So we assume that 5 to the power of 2k minus 24 times k minus 1 is divisible by 576. So now we prove true for n equals k plus 1. How do we do this? Well, again, let's start off by just writing everything down. And so, this is the more advanced proof by induction. So if you've done this more simple ones, you'll notice we can do something cool here, which is 5 to the power of 2k plus 2. Let me just write everything down. 24k plus 24 minus 1. My bad. No. Minus 24. Okay, my bad, guys. So what's something we can do here is we can split this into 5 squared times 5 to the power of 2k. Here, 5 squared times 5 to the power of 2k. Now, we were wondering, how do you get rid of this? How do you get rid of this? Which is this is actually just 25. Like, you can't divide this out of anything. So in actual fact, the way you deal with this, and this is a really good way to deal with the upcoming questions as well, and I'm sure they're going to reuse it in a lot of the questions, and these questions are hard, right? How we do this is we look at the assume true part. We look up here. We need 24, and we need minus 1. We need minus 24k. We need minus 1. This is 25. So actually, we can say that this is 25 times minus 1, for example. Like if we were to factorize this, we could take 25 out and say this is minus 1. So that's solved there. But what about 24? Well, what a cheeky way we can do this is to add 0. And how are we going to add 0? We need minus 24, right? Minus 24k. So what we're going to add is minus 25 times 24k and plus 25 times 24k. And then we have the normal 24k and minus 25 times 1. Now what's going on here? This right here is 0. We technically didn't change the value of this equation. But what we can do is because we need minus 24, we don't need positive 24. What we're going to do is we're going to factorize, and I'm just going to rearrange this to make it easier to look at. So 25 times 5 to the power of 2k minus 25 times 24k minus 25 times 1, and then we're going to have the rest of the stuff here. So just checking, this goes here, this goes here, this goes here, this goes here, and this goes here. Okay. So we're interested in this part, and we want to turn this part into the same part as in here. Well, what we can do is we just take 25 out. We take 25, and we do this. And since we know, we assume that 5 to the power of 2k minus 24k minus 1 is divisible by 576, we then know that the whole thing here is divisible by 576. And so we can disregard it. We can stop worrying about it. Okay. What about this part here? Well, we're going to factorize it again. We're going to factorize 24k out of this. That is 24 times 24. And if you pick up your calculator and do 24 times 24, you're going to end up with 576. Okay. And so this is divisible by 576. And therefore, true for n equals k plus 1. Insane. It's a really cool method, and it's really helpful. So we're going to apply it in the remaining 2 questions. But make sure to remember how to do this, and just keep on top of rearranging your equations, and don't confuse yourself with the different numbers and stuff. But yeah. All right. So we're moving on to this. The tricky thing here, and it's going to repeat the same idea anyways, but it's just here I'm going to skip the let n equals 1 because it's, trust me, I've done it before. This is true for n equals 1. But let's start with assume true for n equals k. This is divisible by 4. Now I prove true for n equals k plus 1. And again, this is just 5 times 5k plus 8k plus 8 plus 3. And if you're looking at this right now and you're thinking, how do we turn this into the same form as we did before? You really, it's weird, but you can't. Well, you still have to add zeros, right? We know that, but we don't have the 25 times 1. We don't have the negative 25 times 1. I mean, how do you split? Like, how do we get this from this? What we have to do is add 2 zeros. We're going to have to add 2 zeros. And this is where making sure you keep on top of organizing it and making sure you don't get confused, it's really important. So we need positive 8k. So I'm going to put positive 8k first. Positive 5 times 8k and negative 5 times 8k. Then we need positive 3. So we're going to have plus 5 times 3 and negative 5 times 3. And finally, we add the stuff here. So plus 8k plus 11. And we're going to do it straight away. So 5k plus 8k. So here, and then let me just cross out that. And then we want to plus the 3. Cross out this. That leaves us with minus 5 times 8k minus 5 times 3 plus 8k plus 11. And I'm going to tidy up this later. But since we assume that 5 to the power of k plus 8k plus 3 is divisible by 4, that means that this whole chunk right here is divisible by 4, and we can neglect it. Moving on to here, we can simplify this. So that's negative 40k plus 8k, negative 40k plus 8k, that's negative 32k. Then we have negative 15 plus 11. Again, that's negative 4. And check this out. We can factorize 4 out of this. And because it's factorizable by 4, that means that it's also divisible by 4. And so we prove true for n equals k plus 1. Again, it's so cool. Just adding zeros. You never expect that to work out. But last question. And this is about manipulating the exponent. Okay. So again, we're going to skip the let n plus 1 part. Let n equals 1. And we're going to move straight on to assume true for n equals k. And so 2 to the power of 2k minus 1 plus 3 to the power of 2k minus 1 is divisible by 5. I'm going to move on. Prove true for n equals k plus 1. And so what you're going to end up here is 2k plus 2 minus 1. That's 2k plus 1. Plus 2, and then minus 1. That's 1. But you want... Actually, let me just expand this. So, plus 1. And then plus 3, 2k plus 1. How do we get from this to this so that we know that it's divisible by 5? Well, we can say that actually if you're a little bit smarter than me when I first did this question, you can look straight away and you're like, hey, 2k plus 2 minus 1, just take the plus 2 out. That's exactly what you need to do. What you do is you say 2k minus 1 plus 2 plus 3, 2k minus 1 plus 2. And this turns into 2 squared times 2k, 2 to the power of 2k minus 1 plus 3 squared times 3 to the power of 2k minus 1. And again, here we need to add the 0. So we look at, let's start with the 2 first. So we want to get this, we need to add a 3 to the power of 2k minus 1. And we need the coefficient of 2 squared. So we're going to add, let me just rewrite this. We're going to, is it add or is it subtract? Yep, you need to add 3k. Okay, so you add 2 squared times 3 to the power of 2k minus 1 minus 2 squared. Oops, 2 squared times 3 to the power of 2k minus 1 and plus the remaining 3 squared, my bad, 3 squared times 3 to the power of 2k minus 1. Let me just check. Plus, minus, same thing, and move this. Okay. So here again, 2 squared, then 2k minus 1, plus 3, 2k minus 1. And we'll simplify later, but if we look here, it's the exact same thing here. So we can say again that this is divisible by 5. And over here, so we can actually simplify this. We can simplify this because it's the same, like if it's minus 2 squared x plus 3 squared x, we can add them together and get the final x. So minus 2 squared is minus 4 plus 9. Minus 4 plus 9 is 5. What does that mean? That means that this is divisible by 5. And there you go. You've proven that it's true. It's true for n equals k plus 1. And voila. So yeah, that's how you do these the harder divisible by proof by induction questions. Make sure to remember how to do the adding zeros and just keep on top of your organization and make sure you don't make mistakes. And also remember these as well. These are pretty important. Anyways, if you you can rewatch the videos, do the questions alongside. Thank you for watching. And yeah.